So the example we have is a ball is projected horizontally from the top of a building of height 19.6 meters. If the line joining the point of projection to the point where it hits the ground makes an angle of 45 to the horizontal. So we have a building top. From there we are projecting a particle in the horizontal direction. So it is going to have a particular velocity, and the height of the building is 19.6 meters. So we know that it will come and hit the ground at some point, right? So that is the ground level. So it is going to hit the ground, and what is said is that the line that is joining the initial point and the final point is making an angle of 45 degrees. So we know if it is a right angle triangle, and when the angle in the right angle triangle is 45, whatever the distance of one side is going to be the distance or the length of the other side as well, right? So that is also going to be 19.6. So we have the distance that it traveled in the vertical direction as 19.6 as well as the horizontal direction as 19.6. What is the initial velocity of the ball? So it is said that it is projected horizontally, so it only has a horizontal velocity. The vertical velocity or the vertical component of the velocity is going to be 0. Meanwhile, we will have an acceleration due to gravity which is 9.8 in the vertical direction, and in the horizontal direction the acceleration due to gravity will be 0. Other than that, we do not know any other parameters. So as always, the ball has a vertical or horizontal projection with a velocity which is unknown, and it travels 19.6 meters, and the acceleration in the horizontal direction is 0, and we have 1 in the vertical direction. So in the vertical direction, the initial velocity is going to be 0 because it is projected horizontally, and the displacement it has covered is 19.6 meters, and the acceleration due to gravity is 9.8 meters per second squared. So we are going to treat as usual. We will take the horizontal component or the horizontal projection and vertical projection. So I'm going to deal with the vertical projection. So we can see that as a common pattern, in problems that are related to half of the projectile, that means it is not a complete projectile because it is not thrown from the ground level, or it is not landing at the same level as it was thrown from. So for problems like that, it depends on whatever the parameters that are given. As long as the vertical displacement or the vertical height or whatever that object traveled in the vertical distance or direction is given, it is better to start off with a vertical projection because we can find the time of flight easily, right? So it is the same equation. So we are going to use delta y equals to VIT plus half AT squared. We are going to use it in the downwards direction. So I'm considering anything downwards as positive. So the displacement in the downwards direction is 19.6. Initial velocity is 0 plus half and 9.8 t squared. So if I simplify it, I would get 4 as t squared. So t is 2 seconds, right? Then I'm going to use, so now that I know the time of flight, I can use the other equations, other component to find the, what do we need? The velocity, right? So horizontal projection. So it is going to be delta x equals to VIT plus half AT squared. I'm going to use it in the horizontal direction, right as positive. So the displacement is 19.6, initial velocity unknown, time of flight 2. So Vx is 19.8 divided by 2, which is 19.6, my bad, 9.8 meters per second, right? So that is your initial velocity, and your time of flight is there. So understand that without finding the time of flight, it is impossible to find the horizontal velocity or the initial velocity. So understand that this is very important. All right. If you have any doubts, please ask. Otherwise, please take it down.